Now see a next device, that is a refrigerator. How does refrigerator work and what is its principle? Now we are going to discuss this, that is also known as heat pump. You know, refrigerator is used for it is a device which is used for cooling the things. Even you can use it for, you know, converting the water into ice, that means for freezing the water. Now see, in this case there are the main parts of this refrigerator. First one is sink. Heat is taken out from the sink, that is Q2. Some work is done on the system, that is a working substance. As a working substance, some gas is used. Now, you know, after that some heat is given to the source. So heat given to the source is Q1. Now see this working, it is actually the working and just like a Carnot cycle, but in the reverse direction. So heat we are taking from the sink, that is done only by doing some external work. So the work is done on the system and then heat is given to the source. So now see here in one cycle, so the net heat dQ can be written here Q2 minus Q1, and in place of the du, according to here this first law of thermodynamics, this equation. So dQ is equal to du plus dW. So in one cycle here the working substance comes back to the initial state, it means there is no change in internal energy. So I have written here change in internal energy is 0. Net heat absorbed in the one cycle is Q2 minus Q1, and the work done on the system, that is taken minus W. So we can write W is equal to Q1 minus Q2. So work done on the system per cycle is equal to Q1 minus Q2. Now here we have to define here coefficient of performance of the refrigerator. It is just like efficiency of the engine. So the coefficient of performance of the refrigerator beta can be written Q2 upon W. So Q2 is the heat taken from the sink in one cycle divided by the net work done on the system in one cycle, that is known as coefficient of performance, this ratio. So now Q2 upon Q1 minus Q2. So the beta can be written here Q2 upon Q1 minus Q2. So by using this here you can calculate coefficient of performance of the refrigerator. Now see here we have calculated coefficient of performance for refrigerator, that is Q2 upon Q1 minus Q2. Now if you take here, that is a Carnot cycle. So in Carnot cycle we have done Q2 upon Q1 is equal to T2 upon T1. So here we can convert beta is equal to Q2 upon Q1, I am dividing by Q1, here 1 minus Q2 upon Q1, that can be written T2 upon T1 upon 1 minus T2 upon T1. Now we can also write beta is equal to T2 upon T1 minus T2. Now in this case here, by knowing the coefficient of performance of the beta, we can tell the efficiency of the refrigerator actually. So if the higher is the value of the beta, more efficient is the refrigerator. Now here also if T1 minus T2 is smaller, that means the temperature difference between the body, that means the body things place inside that, and the outside, if that is the surrounding, if the temperature difference is smaller, then the beta will be higher, that means the coefficient of performance will be higher.